Imagine holding a brand new battery in your hand. It looks completely lifeless. No light, no movement, no sound. Yet inside that tiny object, there is enough invisible force to power a flashlight, a clock, or even start a complex electronic circuit. But here's the question. If electricity is made of moving electrons, what actually makes those electrons move? The answer is voltage. And once you understand voltage, electricity will never look the same again. Before we talk about current or resistance, we first need to understand the force that starts everything. Because without voltage, electricity simply doesn't move. Think of electricity like water inside a pipe. Imagine a long pipe filled completely with water. If both ends of the pipe are at exactly the same pressure, nothing happens. The water stays perfectly still. But now imagine connecting one end of the pipe to a powerful pump. Suddenly, one side has much higher pressure than the other. Now the water begins to flow. Electric circuits behave in a surprisingly similar way. Instead of water pressure, electricity uses electrical pressure. And we call that pressure voltage. Voltage is the difference in electric potential between 2 points. You don't need to memorize that definition. Just remember this. Voltage is the push, the invisible force that tries to move electric charges. Without that push, electrons have no reason to move. Think about a battery. Inside every battery, chemical reactions separate electric charges. One terminal becomes crowded with electrons. The other terminal has fewer electrons. This imbalance creates electrical pressure. The moment you connect both terminals with a wire, the electrons finally have a path. They begin to move, not because they want to, but because voltage pushes them. Every electrical source creates voltage in its own way. Batteries use chemistry. Solar panels use sunlight. Generators use magnetic fields and motion. No matter how it's created, their job is the same, to create electrical pressure. Voltage is measured in volts, named after the Italian scientist Alessandro Volta. 1 volt simply represents a certain amount of electrical potential difference. Some devices use only a tiny voltage. A computer processor may operate at around 1 volt. A USB charger provides 5 volts. A car battery supplies 12 volts. Many household electrical systems use much higher voltages. The exact value depends on the country's electrical standards. But here's something many people misunderstand. High voltage does not automatically mean more electricity is flowing. Voltage is only the force. Whether current actually flows depends on whether a complete circuit exists. Imagine connecting a battery to nothing. The battery still has voltage. The electrical pressure is still there. But because the circuit is open, no current flows. It's like having high water pressure behind a closed valve. The pressure exists, the movement does not. This is why birds can safely sit on high voltage power lines. At first, that seems impossible, but the bird touches only one wire. Both feet are at nearly the same electrical potential. There is no significant voltage difference across its body. Without that difference, almost no current flows through the bird. If the bird touched another wire with a different voltage, or touched the ground at the same time, the situation would become extremely dangerous. Engineers often compare voltage to height. Imagine standing on top of a mountain. A rock at the top has stored energy, release it, and gravity pulls it downhill. Electric charges behave in a similar way. Voltage gives charges stored electrical energy. When a path exists, they move toward a lower electrical potential. This is why every electronic device needs the correct voltage. Too little voltage, and the device may not start. Too much voltage, and delicate components can be permanently damaged. Voltage is not just important, it must also be controlled. In the next video, we'll answer another fascinating question. If voltage is the force, then what exactly is electric current? What is actually flowing through the wire? And how fast does electricity really travel? The answer surprises almost everyone, so don't miss it, because understanding current is the next step toward truly understanding electricity.